So we are back to the main room. And let's see, Dr. Farzana, you were asking regarding the labeling, and we were telling that yes, you can like convert your like text variable as a continuous, I mean quantitative variable by using the option of transform. But in that case, you won't be able to label it. Suppose, for example, this was the blood group. And let's take, because this is in the text like OB and this thing. So what I did, I have transformed this using the option of transform. And if you see this formula, I mean formula means condition. So I've used like if the blood group is A, I will use 1. If blood group is B, I will use 2. If blood group is AB, I'll use 3. And if blood group is otherwise, for O, I will use 4. So I have created this, and then this has come like this 1, 2, 3, 4 again. But in this case, if I have to perform, we will see in the descriptive, if I take out percentage of how many are blood group A, how many AB, how many O, in that case, that output table will not show A, AB, and O. That means you cannot label your variable in this case once you have created the transformation. So you cannot label the transformed variable. That's the limitation. Otherwise, everything else you can perform. Right.
Okay, ma'am. Thank you, ma'am.
Is it okay, Dr. Farzana?
Yeah, ma'am. I understood because now I understood that it's a very tedious process. Again, I have to label
I
and
think,
to check
can I see the
the
chat box?
label of that coding.
Let me see.
Take a note of it. That is just while copy and paste.
Yeah, you can edit that in the Word file. Like that blood, the 4 is O and A is A, AB is 2, something like that. Okay. So now coming to the second session, which is the descriptive statistics. So here, once we understand this concept, then tomorrow we'll see how to do that computation, which we learned today morning regarding the computation using mean and median and mode and all those, depending on the type of variable. Imputation, sorry, not computation, imputation. Sorry, I'm sorry, my bad. So coming to this descriptive statistics. So this is the data and data set. Any data set looks like this. And it is mandatory. Rather, your analysis starts with describing your data. What do I mean by describing your data? That means the different type of variables which are there in your data set. What is the nature of, I mean, depending on the nature of variable, whether it is a categorical variable or a continuous variable, you basically perform this descriptive statistics. Where you descriptive means I'm describing my data. Okay. So because the raw data doesn't carry any meaning and we need to summarize our data set. So this descriptive statistics is a procedure which is used to summarize your data set, your variables in a meaningful way. So what is this descriptive statistics? So basically, if you see, the descriptive statistics means you are summarizing your data. There are 4 types of these descriptive statistics. We'll see like central tendency, then there's a dispersion, then there's a position of the data. So these are the descriptive statistics. In descriptive statistics, since it is performed like taking the total sample and you are not doing the inferential inference, you are not making the generalizability about the population, you don't give the confidence interval. So this descriptive statistics, there's no uncertainty in it. So that's why we say that there's no uncertainty in the descriptive statistics. But there's a limitation that it can only tell you about the people who are there in your sample. It cannot tell you about the population from where you have withdrawn the samples. So that's the limitation of descriptive statistics. So there are 4 major types of descriptive statistics like we have discussed. So the first one is your frequency, measurement of frequency. So like counts and percentage, that is the measurement of frequency. The second is about the central tendency. So this frequency is measured when your data or your nature of variable is categorical. When the nature of your variable is continuous, then you measure the central tendency. Means you see the mean, you see the mean, median. And if the data is again continuous, you measure the dispersion also. So dispersion means you measure the standard deviation, you measure the range of the data like highest and lowest, and also see the interquartile range. And means how much the data, the spread of the data. What is the spread of the data? Any problem?
It was बीच में down हुआ.
Okay. And then there is a position. So this position again, that centile and position of the data. So there are various, there's a percentile. If you divide this 100 into each part, then there's a percentile, then there's a quartile. If you divide that 100 into 4 parts, it's the quartile. And then there are decile. So depending on the division, it's about the position of the data. Then coming your descriptive statistics. So descriptive statistics is you describe about the population, and you not about the population, you describe about the sample, and we don't infer about the population, and we don't do the hypothesis testing. That we mean by the descriptive statistics. Now coming to the inferential statistics. Although inferential statistics we'll start from tomorrow, that is from the chi-square when we measure the association. But just to make you understand the difference between the descriptive and the inferential statistics, in inferential statistics, basically, what you do, you again propose a generalizability. So from a sample, remember in the morning, we discussed about the sample and we discussed about the population. So we discussed that statistics term is we used for the sample, and for population we use the parameter. So through these sample, you predict about you tell about the population, like what will be your you infer about the population. So that we mean by the generalizability. So from inferential statistics, you can do the generalizability. And in inferential statistics, you do the hypothesis testing. So the null hypothesis, the alternate hypothesis, what we know, it's about the hypothesis testing. Because in hypothesis testing, you generally what you do, you frame a null hypothesis, and when you reject your null hypothesis, or you say when you fail to accept the null hypothesis, then you say that your alternate hypothesis is right. So that hypothesis testing is done in the inferential statistics. And you can say that, that population parameter can be, or population estimates can be obtained. But again, it will have some uncertainty. Why? Because whenever you say regarding the confidence interval, actually, I think, even if you don't know about the confidence interval, you know that, there's something which tells about the dispersion of the data. And this confidence interval is about when you project about the population. That means generally we say like 95% confidence interval. So that confidence interval tells you, like, if that study you are 95% confidence that if study is repeated, the other researcher will have the values in between the two boundaries. So that is about the population. So in this, there will be some amount of uncertainty, or some element of uncertainty will be there. So in inferential statistics, you describe about the sample, but you infer about the population also, and we do the hypothesis testing. So that's the difference between the descriptive statistics and the inferential statistics. So like I said, that descriptive statistics is of 4 types. So the frequency or count, it is there for the categorical variable. Like you have just created a categorical variable of age category and a BMI category. So if you take out the percentage, frequency and percentage of these categorical variable, this will be like a frequency distribution. And then comes the central tendency. So central tendency is like for the continuous data. And like you have got mean and median and mode, that's what for the central tendency. And then there is a variability. So variability is for the dispersion. So the standard deviation or the standard error, these are about the variability. So coming to the first, and then there's a position also, like centile and the percentile, 5th percentile or 95th percentile. Then coming to the frequency distribution. So frequency distribution, generally you make the age group. So like I think in the breakout room, you people were discussing like how to do you take like less than 21 or 21 to 30? So that age group, how do you decide which age group you should have? So that depends. There are various criteria. The first criteria is like you can have a like equal class interval. Maybe you can go with the 5-year. Like in case of generally you will see like in case of a fertility statistics, we go with this 5-year interval. Again, you can have some predefined criteria. Like if there is already a cutoff of adolescent, maybe the early adolescent, mid adolescent, and late adolescent. So it has got a biological cutoff. what is early adolescent, what is mid and late, you can use that criteria. Or if you are using like some WHO criteria of having this early, middle and late age, or if you are doing something on geriatric, then what is the classification which has been used. You can review the literature also, what the other authors have used. Why? Because these class interval, whatever you choose, basically you have to show your finding in whether it is in contrast with the other people, other researcher, or it is in line with the other researcher. So that's why you should use either a predefined criteria, which is given by the WHO, some disease cutoff, like in STEP methodology, WHO STEP, which is used for screening the risk factor for NCD. There also they have used a predefined age criteria. So you can use that class interval. Otherwise, you can go with the equal class interval if you are not getting any of either in the review or in the predefined one. Coming to the second, which is the frequency distribution graph. So like histogram and the bar. So this histogram is for the continuous data and bar is for the categorical. And then there is a percentile like quartile, quintile and decile. Coming to the central tendency, you have got a mean. Mean is for if the data is normally distributed, you report mean. You can report median also, but preferred way is mean. And then median is the preferred way if the distribution is a skewed one. We'll come to know how we diagnose whether it is a skewed data or a normal data. And then you describe the mode. So what is mode? Mode is the something which is happening in the greatest frequency. That is the mode. For example, this is the data set of 10 people. And in this data set, you can see like that there is a cholesterol value of 10 people. So if I have to calculate mean, how will I calculate mean? I'll just add all these together and I'll divide this by the number of observation. So this gives the mean, which is the 186.6. You don't have to calculate this. If you click in the software, it gives you the value. But just to make you understand what do we mean by mean, what is median and what is mode, we are just, keeping this, just demonstrating this. And then comes the mode. So mode is the most frequent occurring. So if you see here, 220 has appeared twice. So it is the mode. And then next comes your median. So what is a median? So if the number of observation is even, then you take the median two values, the middle two values, and you divide it by 2. Like in this case, since it is the 10 observations, so I took 180 and 200 and divided 220. By chance it is 220. I did some wrong calculation because ideally it should have been like 180 and 200. And then because this 5th and 6th is the middle two. So, and then divided it by 2. Let me correct it now. So it is 180 and 200. So 380 by 2, it will be 190. So this we mean by the mean, median and mode. But again, you don't have to calculate it. Just to make you understand, we have shown this to you. You will get these values in the software. Coming to regarding the normal distribution. So normal distribution curve is the curve which is again known by it is a bell-shaped curve. We know that. And here, if the curve is normally distributed, which we see by the histogram, we'll see. And again, we see in the case of a normal distribution, if the variable or your data is normally distributed, then the mean, median, and mode coincide with each other. And in this case, the mean is the most sensitive measure because it gets affected by the extreme values. So if there is a normal distribution of a data, you can use both these mean and median to report. Coming to skewed distribution, you can see this is a skewed distribution because this value you can see here, and skewed is towards, we know that it is here the right skew. Why? Because it is still by the direction of the tail. So tail is towards this area, so it is a right skew. So in this case, the median is preferred, and because the mean is dragged in the direction of the skew. and the median is not affected by the extreme values. That's why we report median in case of a skewed data. So now coming to the how will you choose? So if the type of variable is a nominal variable, you go for the mode. And mode is again the frequency distribution again you can give. If the type of variable is ordinal, you can use the median. If the type of variable is interval or ratio, that means scale variable, and it is not skewed, you should use the mean. And if it is a scale variable but skewed, then you should use the median. So this was regarding the central tendency and the frequency. Coming to the third type of descriptive statistics, which is the spread or the dispersion. How much the data dispersion is there. So data dispersion is always calculated by the range. So you first see the minimum and maximum value. That also tells you regarding the what is the spread of the data. It is again, you calculate the standard deviation and you calculate the variance. That also tells you for the sample. That tells you regarding the dispersion, and the standard deviation and variance of a population tells you regarding the population dispersion. For example, in the previous example, we have calculated the mean. So what will be the range in this case? So dispersion, if you see the range in this 10 data set. So if I say this minimum value, so minimum value is 140 and maximum value is 225. So the range of this data set will be from 140 to 225. This will be the range. Next, coming to the standard deviation. So how the standard deviation is calculated? So in standard deviation, you basically measure the difference from the mean. So the mean in the previous slide, you have seen that the mean we have calculated as 186.6. So what you do, you measure the distance of individual value from mean. So how you calculate? So basically what you do like 200 minus 186. Then again 200 minus 145. Sorry, this mean is 186. So what you do, 200 minus 186, 145 minus 186. So here it is negative, right? Because the individual value is less than the mean. So you calculate the distance between the mean. That means like mean minus this value, and then you square this. So when you square this and then you take a sum of it and you divide it by the number of observation minus 1. So this tells you, that's why this is known as the variance. So variance is sum of square. Why we call it as a sum of square? Because it is the square of this difference. So sum of square divided by total number of sample minus 1 tells you the variance. And when you take a square root of it, it gives you the standard deviation. So that is the variance. So remember these terms you will see quite often. What is the variance, especially when you go with the ANOVA? Because when we learn ANOVA, there we talk, most of the time we talk about the variance. And later also, the whole statistics, if you see, the crux is the variance. Variance means how much is the sample, what is the dispersion. So variance is a very important concept. You should remember what is a variance. And whenever someone is uttering this term, you should have something in your mind what that person is saying. So variance is, remember, sum of square. And what is sum of square? It is the distance of the individual data from the mean, square it and divide it by the total number of n minus 1. That is the variance. When you take a square of it, it gives you standard deviation. And when you have to calculate the standard error, what is the standard error? So basically standard error is your this standard deviation, and in the denominator you take under root n, which is the sample size. So this depends on the sample size. That's why you will see that if the sample size is large, that means this becomes very narrow. That means your estimates are very precise. So standard error is generally calculated like this. And then because if it is in the denominator, if it is large number, then your standard error will be small. And if the error is small, definitely we have learned regarding the sampling error and precision also. So it will be more precise. So these terms you should be familiar with. Whether you are doing a meta-analysis or you are doing a advanced statistics like regression and all. What is standard deviation? What is standard error? What is variance? And what like mean, median? So I think you know all these things. So these are important, although very basic, but you should know how we define this. Once again, you don't need to calculate this, okay? It is not expected, like for UG student, we give them the data set. But for you, you should be able to understand the meaning and interpret it. That is only expected. So now coming to the next concept, which is so this was regarding the central tendency. So we have seen the frequency distribution, we have seen the central tendency, we have seen the dispersion, how we measure the dispersion. Now coming to the whether our variable which we have measured, it is the normally distributed variable or a skewed one, that we need to check. And for that, there is something known as the normality, how to check whether your data is normal or not. So for example, like I have taken measured the blood pressure of, let's say 5 people and SGOT level of 5 people. So how to decide whether I should go by mean or I should go by median to describe my data set? So like this is one example you can see here. Here are the values. If you see, just without doing any statistical analysis, you just see these two values. You see this SBP, and in SBP it is like from 110, 108, these values are there, and SGOT you can see these values are here. So if I ask this question, like where the values are less dispersed, then what will be your answer?
SBP.
So SBP is less dispersed, yes, because SGOT you can see that there is one value which is 8 and there is one value which is 210. So rough is to see the range. If it is got a very high range, because if you take out the range, what will be the range? It will be from 8 to 210. And what is the range here? So simply range, if you see, it is 100 to 122. So range is less here and range is very wide here. So whenever the range is wide, you will see there is a more dispersion. So values are more dispersed in SGOT. So whether I should use the mean or median to describe my data, that depends on the distribution. So yes, Dr. Lokesh is right, median for SGOT. So in case of a continuous data set, and continuous means I am now referring all my continuous data as a scale variable. So it may have a normal distribution or it may have a skewed distribution. So if it is a normally distributed, I will go by this mean and standard deviation. If it is a skewed distribution, I'll go with this median and interquartile range. So now how do we define normal distribution? So basically in case of a normal distribution, most of the observation, if you see, they will cluster around the peak. And then the probability, this goes on going farther as you move away in both the direction. So that's why you see a bell-shaped curve in case of a normal distribution. And many natural variables like height, like blood pressure, IQ, that follows a normal distribution. So there are subjective ways of assessing the normality, and there are objective way to assessing the normality. So we'll see these one by one. So first coming to numerical method. So numerical method is like objective way, means it gives you one value and you, based on that value, you say that whether the data is normally distributed or it is not normally distributed. So coming to the numerical method, it is an objective way of judging the normality. It is a very good way of assessing the normality if there is a low sample size. Now, how to define this low sample size? So generally the cutoff which we choose, that is of 50. If the sample size is less than 50, then we have this objective way of measuring the normality. If the sample size is more than 50, then we go for the subjective way, which we'll see. So the Shapiro-Wilk test is the most common test which we use to measure the normality if it is less than 50. And then there is a like kurtosis, and then there's a skewness values also by which you can measure this. So this is regarding the objective way. We'll see in the data set also. Please wait, don't panic that you don't know. We will see all these concepts once again when I will show you on the data. Then comes your graphical method. So graphical method is the subjective way of assessing the normality. In case of a graphical, more experience is required. Why? Because it is like something, when you see a lot of data and when you keep on performing, then you somehow assess that whether it is normal or whether it is skewed. So in this case, what you do generally, if the sample size is more than 50, then you go for this graphical method of assessing the normality. And there are two types of graph. There's a QQ plot, which is known as the quantile plot. And there's another way, which is histogram, which all of us, we keep on doing. That is a histogram. So graphical method is again a way of assessing the normality. So again, to repeat, there's objective way. The numerical method is objective way. Shapiro-Wilk, kurtosis, and skewness is the objective way. And it is good for sample less than 50. If your sample size is 50 or more than 50, generally we go for the graphical method. And in graphical method, histogram and the QQ plot. So like you can use both also, both histogram and QQ plot to see whether the data is normally distributed or not. So like in this case, you can see this distribution. Both these are like a bell-shaped curve. So it is if it is normally distributed, we always go for the parametric test. If it is not normally distributed, like in one group, it is if you are seeing the distribution of some variable in males and in females. So in female, you can see that this is a skewed one. In one group it is normal, and in the other group it is skewed. Then it is the you can say it is not normally distributed. Coming to another one, which is the Shapiro-Wilk test. So Shapiro-Wilk test is a test in which you assume in the null hypothesis that the data is normally distributed. So that's why you want the p-value to be more than 0.05. Why? Because you want in the null hypothesis, you want your null hypothesis to be accepted, because you want your data to be normally distributed. And if you want a null hypothesis to be accepted, your p-value should be more than 0.05. So in this case, the desirable p-value is more than 0.05, and it is more suitable for sample size more than 50. So that is regarding the Shapiro-Wilk test. Coming to the another way, which is the this you can see again some graph. This is the bell-shaped curve. Again, this is again two bell-shaped curve, which is showing the two distribution in different means and same standard deviation. So this height is your mean. So mean is like in this case, means are different, and this dispersion is same. Again, in this case, mean is same, but the dispersion is different. Dispersion is how wide. So you can see here, this is more wide. This is wider than this blue one. So the standard deviation is, in case of this dashed line, is double than that of this blue one. So that means more dispersed, but mean is same. So now coming to the skewness. So if you see the skewness also we have, it measures the symmetry of the curve. What do I mean by symmetry? Symmetry means if I have this, so if I draw a line, so on both the side, it should be the graph should be symmetric. So this is a symmetric graph. This is again a symmetric graph. So this measures the symmetry of the curve, bell-shaped curve, and it is measured with the direction of the tail. And there are two types of skew. There can be right skew or there can be left skew, depending on the direction of the tail which is moving. And for normal distribution, the value of this skewness should be plus minus 2. It should not be more than 2. Similarly, there is something known as the kurtosis. So what is kurtosis? It measures the peakedness, means how tall your bell-shaped graph is. So if it is very tall or if it is less tall, then that means it is not normal. So more peak or less peak than the normal curve tells you regarding the not normal distribution. So if it is more curve, more peak, we call it as a leptokurtic. If it is less peak, we call it as a platykurtic. And again, the same value as for skewness. If the value of this kurtosis is within plus minus 2, we tell it as a, we call this variable to be a normally distributed variable. So, three numerical ways of assessing normality: Shapiro-Wilk test, this skewness, and kurtosis. The p-value of Shapiro-Wilk should be more than 0.05 for the data to be normally distributed, and the value of this kurtosis or skewness should be within plus minus 2 if you want your data to be, no, I mean, in case your data is normally distributed. So this is just some graphical presentation. You can see here it is skewness value will be more than 0 because the direction of the skew is towards the right. It is the tail. Here the skewness value will be less than 0 because the direction of the tail is towards this graph. Here it is it is very few observations. You can see very peakedness is there. So the kurtosis value will be more than 0. And if it is like a flat one, then your kurtosis value will be less than 0, which is a platykurtic. So again, this was regarding the numerical way. There is another way, which is the subjective way of assessing the normality. So what is the subjective way of assessing the normality? We learnt about the histogram and the QQ plot. So this is histogram, which plots the density against that variable. And then the next comes your QQ plot. So what is a QQ plot? So QQ plot is, we say that it is one of the best method to assess the normality if the sample size is more than 50. Again, if the data is normally distributed, you see that there is a diagonal line and all the individual data point that will be again like along that diagonal line. Then we say that it is a normally distributed variable. So normal QQ plot, you can see here the dots. Here the dots are, these are the individual data point. So they are along this diagonal line. That's why we say that it is a normal distributed curve. Again, this also you can see it is a normal distribution, normal distributed. And then comes a box plot. So what is box plot? So box plot is basically to see the outliers. Remember in the morning session, we learned about the missing values and outliers. So outliers are abnormally high values. So this is the box plot. This we have drawn like horizontal. So how this box plot looks? So in box plot, this is the box, which is, it is also known as the box and whisker. So this is the box and these are two whiskers towards each side. So this length, the breadth of this box, this tells you the interquartile range. And this median line, which is this yellow line, this is the median of this data. This is the 25th percentile, which is the Q1. And this is the 75th percentile, which is the Q3. That's why we say that Q1, difference of Q1 and Q3, that means 25th and 75th percentile, it is the interquartile range. And then you describe about the outlier. So this is the outlier to here. So minimum value is, it should be like less than 1.5 box length. So that is your minimum value, minimum range. And the maximum should be like Q3 plus 1.5 box length. And this box length is the interquartile range. So any values lying outside these two whisker will be your outlier. So how we define outlier? Any value which is more than 1.5 box length from the edge of the box. Because if this is the edge, if you see, this is the edge of the box. So any values lying outside the 1.5 box length of on the either side is the outlier. This is just the definition which you should know. Otherwise, in JAMOVI, it gives you the outlier, total number of outlier, and the serial number of the outlier, which data point is the outlier. That also it tells. So now we'll see in the JAMOVI. These are few graphs. This is again like density plot. This is histogram over density. These are like, this is the way it will appear. You can see the box plot appears like this. This is the box plot. This is this median. The dark line is the median. And this, the quartile 1 and quartile 3. And then it tells you this is quartile 1. So any values outside these two. Similarly, this tells you regarding the all these outliers. So this is outside the 1.5 times box length. So these are the outliers. This is again the violin plot. This is also plotted in the JAMOVI. And this is the QQ plot. So now we'll see frequency distribution and the normality of the continuous data and the descriptive statistics. I think there is an exercise also. Let me open session. So you have to open this Microsoft Word document. And I'll tell you, data set, like we have got the data from you people also, which is the 7th basic JAMOVI, but we could not do the cleaning. So that's why this demonstration for demonstration and for your practice, we are using the data set, which we have 6th JAMOVI. Okay, because that was a clean data. So that's why use this folder, this file. It is there in your drive. Please use the data set like this JAMOVI file of 6th basic. So if I see the question, so first I need to perform the frequency and percentage distribution of age group, gender, state, region, and monthly expense. Okay. So let's see all categorical data you can see. So this is the data set. I have opened this data set. You can check. Just go through the data. What are all? So it is the BMI, SBP, DBP, hypertension grade, the normotensive, hypertensive, and pre-hypertensive. And then diabetes, like yes and no. These 4 are the PHQ questions. This is the total PHQ score. And we have classified the PHQ score taking these cutoff. So cutoff, like if the total score is from 0 to 2, there is no clinical significant symptom. If it is 3 to 5, then it is mild. If it is 6 to 8, then it is moderate. And if it is 9 to 12, it is severe. So taking these, we have converted these variables. So you can see it is the moderate, mild. Like if it is 0, it is normal. If it is 5, if it is 6, it is moderate. And then again, the first 2 questions are for anxiety and next 2 for the depression. If you see the questions, the first, there is an anxiety subscale and there is a depression subscale. So first 2 questions are for the anxiety. So any total score more than equal to 3 suggests the presence of anxiety. And the next 2 question is for the depression. So feeling down and little interest is for depression. So total score more than equal to 3 suggests the depression. So that's why we have categorized these into the 2 variables. Anxiety total score and then anxiety category like yes and no. Similarly, the depression total score means the last 2 questions. And then depression, yes and no. And now we have also classified this water intake like 2 to 4 liter, less than 2 liter, and more than 4 liter. So this we have created, and this again, there is a physical activity, minutes, the classified it, screen time, and classified it on the basis of whether it is 2 to 4 hour or average screen time. Then again, sleep duration and the commute time. So how to do that? Again, during the this thing basic of JAMOVI, I forgot to tell you regarding the options. So if you come to this analyze, then you can see a plus sign here. So this plus sign is for installation of module. So if you click this, it tells you regarding what are the modules which is there in the JAMOVI library and what is there in the installed. So these basic one you will have like linear model and med decide survival. This I have downloaded. So right now I'm not telling you how to download the others, but again for basic, if you need some other module to analyze, like if you want to do the scale development and all, and if you want to go for the factor analysis, then I'll go to this and I will write here available light factor. So like snow cluster is there. These are the two variables which it is showing. So either you can like update it. It is already there in my this thing, or you can skip that. But for here from, you have to see like what are the installed ones. So these are the installed one in my this thing, and this is available. So these options you can see. Coming to the another option of, here you can see there's a 3 dots. So if you click that 3 dots, you can see the like, you can again change your format of the result. If you want your p-value to be 1 decimal point or 2 decimal point, you can change that. Like minimum is 3 decimal point, and this number format also, if you want like 2 decimal point is the minimum one. And then plot also, you can, we'll see this plot one. And again, version you can check from this thing here. This is your version. Version 2.6.26. We need to see this. Why? Because there are two versions which are there on my PC. That's why I need to check this, whether I'm working on the 28 or 26. So coming to this descriptive. So descriptive comes from this option of exploration. This exploration. So click on this exploration, and here you can see there is a descriptive. So click on this descriptive. Now you can see here in descriptive, I need to see the frequency distribution. So I will select all the categorical variables. So age group, you can move gender, state and union territory. And if you click that statistics, it is by default, it is clicked. And it will give you the like this mean and median of gender also, but that doesn't carry any meaning because it is a categorical variable. So I'll uncheck all this. By default, it is clicked, standard deviation, minimum and maximum. And then I can click this frequency table. You can see, if I click this frequency table, you can see it gives you the frequency, like what is the frequency of less than, and the counts and percentage. Similarly, the gender, the state also, it gives, you can have like monthly expense category also. So 10,000 to 2,000. So here there's a feature. When you have created this less than 10,000, that has gone down here. But when you have, when you give your table, you want this less than 10,000 to be at the first place. So how you will do that? You go to this variable section and you click on this data of your variable of monthly expense category. I will double click this, and here you can see this sign. Can you see there is a sign of this moving up and down? So what you can do, this select this and keep moving it up. So now this less than 10,000 has come, and now you see your result. So you go to this data. Now can you see this less than 10,000? It is appearing on the first, and then it is 10,000 to No, 19,000, I mean up till 20,000 and 20,000 and above. So you can move these variables also. And again, you can see how dynamic it is. Those of you like Farzana and all those of you who are working on SPSS, you know that if you have to again redo something, it creates another output. So it will keep on adding output how many times you repeat your analysis command. But in this case, JAMOVI, once you are finalized that you want to keep this analysis, then you save this result. Otherwise, there's no need. So that's a very, I mean, I found it very useful. And the interface is also very, so like if you double click on this interface, this window will appear. Again, you can perform many other, like if I need to, again, I will put this blood group transform here, which I have transformed Farzana. That again number two. So here you can see, it gives you the counts percentage. What is 4, 3, 2, 1. But it doesn't tell you what is 4 and what is 3 and what is 2 and what is 1. In that case, again, when you copy, how will you can do that? You right click this, copy this table, you go to Word document. I'm just pasting here. And then here you can like edit it. Like what is 1, what is 2, what is 3. Okay. So this is how you need to edit it in the, because it's a format of Word only, Microsoft Word. So here you can add, because if I can recall, the one was A. So I can write it as A blood group. This 2 was B. 3 was AB. And 4 was O. And this, like you can edit this table. So any other variable also you can put. This was regarding the frequency, means you need to see which, and frequency, if you see, frequency can be there only for categorical variable. So what are the two categorical variable? Nominal and ordinal. And these signs will tell you that this action, this particular command can be performed only with these type of variables. That's why please check whenever you import the data, always go to this variable and individually click each variable and see the nature of the variable. Whether it is continuous, keep on doing like this and this. Check the variable. That helps you in having the the correct type of variable in your data set. This is regarding the frequency. Again, if let me go to the another exercise. I have to show the frequency across any. So like cross tab. This is the frequency and percentage of blood group, RH status, BMI group, hypertension and diabetes. So again, the same thing you can do here. I can, again, if I move these back to this group, and if I want to save this, what I will do, you can click on this all analysis, and then first you can duplicate it. If you duplicate it, the upper one analysis will go up. It will be there in your system if you save it. And now I can move these back. So this will go back and this will disappear. All this will disappear. So now I can move another variables. So what were those? Like, let's say BMI group or hypertension grade, diabetes status. If I want to see how many of you are like PHQ, so you can see in this data set, there are like 41% who are obese, 8% are underweight. Similarly, and you know how to write. So you can write your description here also. I can write here that the percentage of obesity or obese was 41%. 41%, followed by, you can write like normal, and then it was overweight. So you can write your description also here, but again, you can copy this table in the Word and write description there also. And you can duplicate your analysis, which is there. Why? Because if you move the variable back to this window, this will disappear. So if you want to save your analysis, you keep on duplicating your analysis and then performing next. You can see this is normotensive. So there are 18% of the people who are hypertensive. And if you see this one, diabetes, so only 4% were diabetic. And 35%. Now again, if you see this, what can you see here? Normal is they are in between severe and moderate. So I don't want this. So I want this normal to be on the first place, followed by mild and moderate. So I'll again go to this variable and go to this category of this one. I will double click this, and this normal I'll select, and I'll move this back. So now this is normal, mild, moderate, and severe. So this thing is there. And so this is how you perform the frequency. So this is one this thing of frequency distribution. Now if I see the next question, again blood group RH, total score, this I have shown you. You can take out the frequency distribution of dietary preferences, water intake, screen time. Again, I can see you can add few more. Depression category, dietary preferences, water intake category, physical activity category, screen time category, all categorical data, commute time category. So you can see like this buffering is happening, and it will give you the output. So all, but again, it doesn't merge the table. So if you need to club your analysis or give a one table merging the tables, then you need to you need to draw, insert a table and put these specific values. This doesn't merge the table. JAMOVI. So here you can see like all the categorical data table is there. Right. And then this we have seen. This is just to show, like, if you want to show like per count, we don't give cumulative percentage, okay? This column we don't write. It is especially for the students, the postgraduate students, or people who are the mentor, that whenever you see, because main time what students they do, they directly copy paste this JAMOVI table and then they write the result. But you need to tell them that this cumulative percentage, it is not needed. It is for you, but it should not be there in the thesis or in a project, this thing, project report. And this is again, this is how you can write like count and percentage. And here we have like merged the table, like distribution of health and physical matrix, where you can see blood group, the RH status, BMI category. Like we have merged this, but JAMOVI doesn't give a merged one. You need to enter the specific values in this table. Okay, now there's a cross. I mean, in JAMOVI, you can make a cross table also. Cross table means like distribution of dietary preference across gender. So how I can do that? What I'll again move these variables back. So how can I do? Go to this, press shift, come down, and again press, double click this. All get selected and you can move these back to this window. So I have to do the dietary preferences across gender. So I'll move these dietary preferences here and gender here in this split by. Here you can see it should be a nominal variable. So it tells you regarding the male. What by mistake?
By mistake ऊपर किसी ने other लिख दिया.
Okay, someone has written other
अब ये
in
पूरा
this.
outlier type का.
So that's why you can see like 1, 2, and there is a one data is for other also. So this you can see 15% females are this 1 and 2. So dietary
One vegetarian.
one was vegetarian. Let me see the coding, and you can again go and write it. Let me go back to the variable and dietary preferences. But if I have created that, you cannot have.
Now
I need
get
to go back
one
now.
to database for this one.
Hmm.
One to vegetarian.
So I will write here vegetarian, and 2 is the non-veg. Now it. And if you go back, you can see like veg and non-veg. Then you can see like in vegetarian, 15% there were females and 25% male. In non-vegetarian, there were 22% females and 37% males. So that's how you can have a cross tab. Cross tab. Similarly, there are other cross tab like prevalence of hypertension grade across gender, physical activity across gender. So what I can do, I can create this physical activity because gender is already there. So I'll move this physical activity category, the screen time category, and then you can see here like in 30 to 60 minutes, what is the distribution of male and female? Above 60 minutes, less than 30 minutes. Again, the screen time category, this thing also 2 to 4 hours, less than 2 hours. And again, you can correct these sequence. If you go back to less than 2 hours is appearing in between these two variables. So by going to this again,
ये प्रॉब्लम कोडिंग करते समय नहीं होगा कोडेड पे.
so I can go with this. So it has appeared. So this is regarding the
डायनेमिक सीक्वेंस का ये फायदा है. बाकी जगह फिर से रीलोड करना पड़ेगा.
this was regarding the categorical. Now I'm not, there are many this thing, I'm skipping all these. Now coming to the for continuous variables. For continuous, I need, these are some, we have shared these sheets. Now coming to the continuous variable or the scale variable. So scale variable is like, I have to do the normality testing of all my scale variable. So I'll again go here. You can duplicate your result. So how I'll do, I'll select this analysis and I'll duplicate this. So this gray color, if you see this gray, that means it has duplicated, and this white is for active sheet. So now what I'll do, I'll move this gender back to this window and I'll select all these 3 variables. Now I will uncheck this frequency table. Why? Because now I want my continuous data. That means my scale variable. For scale variable, what I'll go with the central tendency and I'll see the dispersion. So let's see, I'll start with age. First, I'm moving all the variable, the scale variable. So monthly expense, age, you just see these sign. That's why when we were creating variable or when we were just checking the variables, these signs are important. So right now, I don't need to think like whatever sign it is there. Let's say it is SBP, DBP, PHQ total score, anxiety total score, depression total score, average daily water intake, physical activity, screen time, sleep duration, average commute time. So all the continuous variable I have shifted to this window. And then I will see what all I will see. I'll see mean. Right now I'm seeing everything. Median. You can check about the percentile, cutoff point for 4 equal group. You can click on the 25th, 50th and 75th percentile, which is the position. You can click on the standard deviation, the variance, the range, IQR. You can see the distribution, skewness and kurtosis. You can see these Shapiro-Wilk. You can see the plots. If you come to the plot, so first we'll see the data, then I'll show the plot. So if you see the sample size, what is the sample size? Sample size is 170. There's one missing data. So 170 is, so should I use the, so first let's discuss, should I use the subjective way, a numerical method or graphical method of assessing the normality? Which method I should use? Yes?
Subjective.
Subjective way. Yes. So I will not go with this Shapiro-Wilk. Otherwise, because why Shapiro-Wilk I will not go? Because Shapiro-Wilk will always be less than 0.05. And less than 0.05 means my data is not normal. If you see the Shapiro-Wilk, see in all data set, the p-value, we see the p-value of Shapiro-Wilk. So the p-value of Shapiro-Wilk is always less than 0.05. So you will always say that data is not normally distributed, which is not the case. So I will just enlarge this. If you click this smaller arrow here, up here. So I want to show you all the table because I have clicked many variables. So I have clicked like this. But it is not moving. It is not. How to, oh yes, now it is there. So you can see this. So now we'll see one by one. So this is, if you see all the variables, although we are not going to give all the variables in one table, but just to make you understand, if you see the data, this is the mean of age, this is the median of age, this is the standard deviation, this is the variance, this is the IQR and range. The kurtosis value is 0.82 and the skewness value is 1.3. So we have discussed that if it is within ±2, it is normal. And these are the percentile value, means at the 25th percentile, it was 19. You know the percentile, if you arrange your values in ascending or descending order, let's say we have arranged it in ascending order, then your 25th percentile at 25th value, it is the 19 year of age is there. At 50th, it is the median. So you will see that this 50th percentile and this median will be same. This 50th percentile and this median, it will be same because median is the 50th percentile and this 75th percentile. This you can see. What I can do, you can change the view of this table also. How you can do that? I will go to this analyze and I can, there you can see descriptives, variables across column. Here you can change it to variables across rows. And then your variable will come here on the row and it will go there, that side. So now you can see here all the mean, median and these variables. So these are the values you can see. Skewness, if you see the skewness, this variable, if you see 3.4. So again, you can use like skewness and kurtosis also you can use here. Again, you can see this variable, more than 2. If you see kurtosis, This is 14. This is 6. This is again. So these values are higher. And again, Shapiro-Wilk, so I have asked like you should not use Shapiro-Wilk. And these are the percentile. So this is regarding the, here since it is sample size, so this is regarding the various measure of the percentile and the mean and median, skewness and kurtosis. Coming to your subjective way. So for this, you need to see the plots. So I'll plot, let me move, okay, I'll plot this histogram and density and QQ plot. I'll again plot this box plot and I will label outlier. And then I'll wait because there are many variables. It might take some time. So you can see here, it is buffering and it is taking time. So go systematically. Whenever you have got your data set, first perform all descriptive and see the nature of the data. By this, you will have rough idea also. That I have told you. Someone has, okay, Dr. Lokesh, the cutoff of kurtosis is ±2. Remember when we were discussing the descriptives, we discussed this again to repeat, cutoff of pi ±2 because the platykurtic or leptykurtic means it can be a flatter one or it can be a very peaked one.
Madam, shall I ask a query?
Yeah, Dr. Subhapriya, please.
Madam, like now we are finding out that now we are going to go for a histogram and density like subjective assessment. Now, what do we do with this skewness and kurtosis Shapiro-Wilk values? Like, do we need to have it or we can just take it
You
off?
should know it. No, you should know it.
Okay.
Means
So
what to do means what you want to say. See, it depends. What is, if you are doing a publication or a manuscript publication, these things are not reported. Okay. These are for your own, like when you have to do advanced analysis, you should know because there are many assumptions. Like if you are going for an ANOVA, you say that your dependent variables should be approximately normally distributed. Or if you are going for, there are parametric and non-parametric. So for those analysis, you should be having these basic statistics, checking the variables. Otherwise, generally in manuscript, you don't write these kurtosis or skewness. This is only for making a decision to label a variable as a normally distributed variable or a not normally distributed or a skewed variable. Okay.
Okay. Okay. Thank you.
Otherwise, for PG thesis, like for our PGs, we ask them to report each and everything. Each and everything. Why? Because by that they will learn how to describe the data. Because the purpose of a PG thesis or a dissertation, even if it is a PhD thesis, we ask them to describe the data in detail. Why? Because the purpose is to understand the research and understand the data. So there maybe they have got this flexibility of having so many pages. There is no limitation of space. But in this, what to say, publication, you don't have that leisure of, doing writing as much as you think or as you wish. Okay. So,
Okay, madam. Thank you.
So this, you can see here. This is the plot. Here you can see the age. And you can take more than one way. Like here, I'm not very sure whether this is, if you see the age, does it look like a normally distributed or a skewed one? To me, it represents the skew. And this is the direction of the skew towards the right side. So it's the right skew. And these are the outliers. If you see the box plot, the serial number 35, 54, 8, these many outliers are there. Here also, if you see the median, remember 22 was the median. So this is the median. And 18 was the 25th percentile. So this is the 25th percentile. And this is your 75th percentile. And this length of the box plot is the quartile range. Coming to this QQ plot, again, if you see the QQ plot also, these individual data points, they are not across the diagonal line. It is down and then again it has gone up. So by the frequency distribution of by this histogram or density plot and this thing also, age is not normally distributed. It is a skewed one. Coming to monthly expense, yes, what is your comment? If you see this, again, not normally distributed. If you see the outlier, there are so many outliers. You can see how many outliers are there. And if you come here, again, if you see this is again not normally distributed. Come down. This is your BMI. BMI is approximately normally distributed. It is approximately normally distributed, you can see. If you go down, there's only one outlier in BMI. And again, if you go down, now you can see this is a very good QQ plot. Most of the data points are across this diagonal line. Can you see? So now I can say yes, BMI is normally distributed. Am I making sense to all of you?
Yes,
Are you able to understand?
yes, ma'am.
Yes, ma'am.
Okay, thank you. And then you come down. SBP. Now you have to answer. What is your interpretation? SBP? Yes, somebody is saying something.
Geeta, ma'am.
Yes,
Ma'am,
Dr.
actually, the
Geeta.
diagonal line represents what, ma'am?
Okay, diagonal line is the line. You don't go into that detail, but if you see, there are two values. There is a theoretical quantile and there is a standardized residual. Because if you have asked this question, then I have to make you understand regarding what is standardized residual, what is theoretical quantile.
Normal distribution.
So you don't go into that detail. You just remember that if it is across this diagonal line, then it is normally distributed.
Okay, ma'am. Okay, thank you, ma'am.
Yes, Dr. Farzana?
Just I have a question. अगर हम लोग डेटा डिस्क्राइब करना चाहते हैं तो जस्ट वी नीड टू डिस्क्राइब ओनली इंडिपेंडेंट वेरिएबल ओनली और आर आउटकम ऑफ इंटरेस्ट आल्सो
All variables.
then again my question is like कि अगर outcome of interest will vary depends on the group, like in my case I'm exploring the outcome among the COVID infected and non-infected women. So दोनों में outcome तो अलग अलग रहेगा. So there is no need to like कि उसमें normal distribution नहीं देखने मिलेगा. Am I right? Or
Actually, see, if you describe, so there is a distribution, these thing you can see. Right now, I am not seeing it across any category. Here, if you come, I'm seeing overall. Again, here, you may have one category, like you are saying, the COVID infected and non-infected. So I may include this gender here, okay, split by. And then you see the normality, because when you see the paired t-test and independent sample t-test, you check the normality in that group, different group. So I have to see this across gender. This is just for one example, like you are saying, na, COVID infected and non-infected. So you have to check the normality across in these two groups. And now check that. Not overall. So there are two ways. First, I am checking the overall normality. That is one exercise. When I will again go for ANOVA and independent sample t-test, I will check it across group. Whether like ANOVA may it will have more than two category.
okay.
It is not for other people. So please, if other people are not getting it, don't think that you don't know. Since Dr. Farzana has asked this question, so many times when you have to perform the analysis, you have to check the distribution in a specific group across. So like just now, that overall it got broken down into two. So now I again, so suppose this is gender. You can see age is, in case of a male and female both, the case it is not normally distributed. And there are more outliers in male than compared to females. If you come down, again, the same concept, it is not distributed. Monthly expense, again, same. Outlier. Again, if you come to BMI, both are normally distributed. So both QQ plot normally distributed. So you can check overall also, or you can check across a group also, depending on your requirement. Here's also SBP. If you see, it is like, you can say roughly normally distributed. DBP again, if you see this is not normally distributed, this is supposed to normally distributed. So one group in female, it is not, but in male, it looks like. So here you can see it is more, and it is a little straight here. Coming down again, PHQ, again not normally distributed in both the group. Anxiety again not normally distributed. Depression again not normally distributed. You can see the QQ plot. Average daily water intake, to some extent, yes. This one, especially this in the male. So you can see here to some extent, but not a very good, not very good distribution curve. So this is how you can check, like for each. So if you like don't put this split by, then it gives you the overall. Otherwise, it gives you in that specific group, that distribution. Is it okay, Dr. Farzana?
Yes, ma'am, I understood, and just I will need some more guide maybe in future. So for that, I'll contact you personally. Like if for my PhD thesis, how should I go ahead? So that I will
Okay.
contact you
Okay.
personally.
And in that, since if it is your PhD thesis, you can go to any extent. Means of course it will be dependent on time. Means you have got a flexibility, like you can write. So the more you describe your data, it is good for you.
Okay. Thank you. Thank you so much, ma'am.
Breakout room.
Okay, so now we can go for this breakout room.
Second file use करना बता दीजिए stage 2 6th वाला and
Hey, stage this you
Ah.
use this
I prime and frequency and descriptive is for question
this you use 6 basic JAMOVI data set
interact.
and use this Word document, demo, frequency, and descriptive. We have shared these 2 files.
And the breakout.
So Swapnil
or Ankit.
or
Yes,
Ankit,
ma'am.